Spectroscopy separates the wavelengths of light, and differences in absorption or emission of photons in different regions of the electromagnetic spectrum are related to different types of molecular motion or electronic transition. Now, microwave radiation is associated with transitions in molecular rotational levels. So when a photon interacts with a molecule, the molecule rotates, or if the photon's not at the right energy level, it just passes through the molecule. Now, infrared radiation is associated with transitions in molecular vibrational levels. So for example, if this H2O molecule absorbs a photon, then it vibrates based on its molecular geometry until the photon is emitted. And with the CO2 molecule, which has linear geometry, the oxygen atoms oscillate back and forth. And when a molecule absorbs a photon in the visible light spectrum, then the molecule gains energy and becomes brighter. And it loses energy or becomes dimmer when the photon is emitted. And similarly, in the UV light spectrum, the molecules gain energy, and in addition, bonds may get broken because the electrons can be ejected. So as we move up the electromagnetic spectrum, you get higher frequencies and smaller wavelengths of light.